Hello and welcome to IEEE Soft Robotics podcast. In this podcast, we're going to interview researchers from both academia and industry about their work, thoughts, spectrum, and more beyond that. This is Marwa Edwini, and I hope you will find this podcast useful. If you would like to connect with us, simply send us, and we will be happy to hear from you. And here is my interview. Thanks.
I would like to ask you first how you would like to define yourself, maybe for the audience, maybe first time listening to you, how you would like to define yourself?
Yeah, I'm an assistant professor at Stanford. I also spend a little bit of time at the Robotics at Google team as well. I view myself as a scientist, a researcher, and I'm especially excited about robotics and machine learning.
Great. So we ask you guys about their childhood. I'm curious to ask you about your childhood. Do you have any memories about your childhood, being interested in science in general? Any memories about your childhood?
Yeah, I think that when I was a kid, I really liked solving puzzles and solving jigsaw puzzles, for example. And in many ways, I view research as trying to solve one giant puzzle, maybe a few sections or pieces at a time. And that's one of the things I really love about my job and about what I do. I also, when I was in middle school, I also worked a little bit with Lego robots built out of Legos. And I also enjoyed that a lot as well, both kind of, trying to figure out how to solve problems by building these kinds of robots.
Great. So actually you have doing a great work, of course, about MetaLearning and multitasking and learning in general. But I'm curious to ask you in the beginning, when you look to the robot and the learning you try to do, what technique to use. When you look to what we have already, the robot, we have an argument to debate about the brain and the body, which one we have to invest more. So from your work, how do you see intelligence in robot? Do you think we have to invest more in the body itself, how the shape of the robot or the functionality to design the hardware, or the more in the brain, from your experiences and working what you do, maybe generally? Yeah.
Definitely. I think that there's certainly investment that we need to do on both fronts. And for example, on the body, I think that things like better tactile sensors that have all the properties that the human skin has, for example, would be really amazing and fantastic. And also like compliance. And I think there's certainly a lot of work to be done on the hardware front, but I think that there's much more work to be done on the software, on the mind, on the brain of the robot. I think that, for example, if you teleoperate a robot, you can actually have the robot do a lot of different things if a human is controlling it in a variety of different environments. And if we care about robots moving into places that humans are and helping humans and acting intelligently, I think that we have so far to go to get to that point. And I think that it's, in my opinion, primarily in terms of the software and how to actually figure out how to control the robot, perceive the surroundings, and so forth.
Great. So when it comes to learning, because you mentioned a lot of time about how we can have a learning to kind of adapt, for example, when we have an open-ended environment or something, it's changing environment, and you aspire to have generalized and adaptable as well as continual learning. When you look to, for you, you research, what kind of maybe trying to something you see a limitation, what we already have to examples of administration, we have it already with human interacting with human, for example. What kind of something do you think is missing for you? And you try to maybe to invest more approaches for advancing learning.
Yeah, I think that there's so many different things missing. I might start by actually just motivating why I use learning in the first place. And in particular, because the world is so diverse, and when you go into a new place, a new room, like you're going to be in situations where you see objects that you've never encountered before, where objects are in configurations that you've never seen before, and so forth. And there's just so much variety to that. And in particular for building robot arms and building robots that can interact with objects and manipulate them in certain ways, I think we can't just think about hard coding certain behaviors because of this variety. And because of this kind of the sheer diversity of all the objects that exist in the world, all the configurations and so forth. And so I think that this is a big motivating factor for using learning, to have the robot actually see the kinds of environments that exist in the real world, learn how to solve things from experience, adapt to new environments, and so forth. I think that if you don't have any learning-based component, just trying to handle the kind of sheer complexity of the real world is overwhelming in some ways. And then on the learning front, and once we decide on using machine learning and using learning-based approaches for robots, I think that there's a number of different challenges and a number of things that are missing. First, I think that we have a tendency to have robots just start training for a single task from scratch. So the robots say, okay, I'm going to learn how to do a backflip today. Let me start from nothing, assume that I know nothing about the world, and have this trial and error process. Or maybe I want to, I don't know, learn how to pour water or something. And I think that this tabula rasa learning, where we're just starting from a completely blank slate, is really problematic, because then you're never actually really accumulating knowledge and accumulating experiences and so forth to allow the robot to ultimately perform a wide range of things and be able to perform well in a wide range of environments. So that's one challenge. I also think that the way that we think about data in robotics also needs to shift a little bit. This is related to what I was saying before, but I think that we have a tendency to think about robot learning as this online collection process where we start from scratch and collect data and the robot learns something. However, if we look to the rest of machine learning, the paradigm there is we collect a data set and we use that data set many different times. We train on it, we reuse it multiple times, maybe for different tasks, maybe for different purposes. And also that data is not just used by one lab and one robot, it's used by the whole community, right? And so I think that we need to start thinking about doing this, because if we want robots to accumulate lots of data and see lots of the world and maybe accumulate years of experience, just like how humans are able to accumulate years of experience, then we need to think about how we can share data, how we can accumulate data rather than collecting data for each individual project and so forth.
Great. So that's maybe if you can tell me more about why you're interested in MetaLearning. I think that's answer why you're really passionate about that. But if you can tell more of the audience about MetaLearning, why you think maybe why you are so curious and passionate in your research, and still, yeah, there's a lot of limitation challenges. Also, new paper, also is very interesting. So, if you can tell us more about why do you think maybe MetaLearning here is maybe could be solving these challenges you mentioned.
Yeah, absolutely. So MetaLearning essentially provides us one way to avoid starting from scratch for every task. Essentially, it provides a framework for reusing experience from existing environments and existing tasks to allow us to take that experience, condense it into some form of prior knowledge that allows us to much more quickly learn new tasks. And the particular mechanism that it typically does this is you essentially learn how to learn all of your previous tasks. You learn this prior that allows you to quickly adapt to any of these past tasks, so that when you see a new task or a new environment, the robot can learn much more quickly by leveraging this kind of condensed form of prior experience and prior knowledge. I don't think it's the only tool that will get us to some of the challenges that I was describing, but I think that it's one useful tool for thinking about this. And one nice framework that, at least conceptually, that allows us to reuse experience in a way that that is somewhat satisfying. I don't think it's the final answer, but it's certainly shown some promising results. And also beyond robotics, it's actually been pretty cool to see lots of different areas that you can apply it to as well. People have used it for drug discovery like problems where you want to adapt to new molecules. People have used it for land cover classification, and other problems as well.
Yeah, but I'm curious, do you have any scenario like maybe MetaLearning could be fail in certain like problems, or something is still for you is challenging, that's something you need to figure out why it's just failed a certain scenario, or huge limitation, do you think? And do you also think about hybrid approaches? Do you think, how do you see this kind of hybrid learning, for example, if you use MetaLearning and other way technique as well?
Absolutely. I think that one of the central challenges is that MetaLearning makes this assumption that your previous experience is organized into different tasks, and that the future things you want to learn is also a task that is somewhat similar to the tasks that you've seen before, or at least from the same distribution of tasks that you've seen before. And oftentimes maybe your previous experience is just a stream of data, a stream of experience coming from the robot sensors, and it doesn't obey this assumption that you have this kind of structured data into different tasks. So I think that's one core challenge with the framework, and there are some approaches that try to take a stream of experience and then structure it into different tasks and so forth that allow you to leverage it. But it's still in some ways, I think, an open challenge. And I certainly think that more hybrid approaches could make a lot of sense, maybe combining ideas from unsupervised learning with MetaLearning, or thinking about different ways to leverage previous experience in a way that allows you to adapt to new settings.
Yeah. I'm going to ask you, I don't know if through your work, do you have any kind of experiences about something you thought would work out in a certain way, but maybe while you tried to read robot was counterintuitive, or you didn't expect a certain result like that? Do you have any kind of scenario like that happen to you and was surprising or counterintuitive result?
Yeah, certainly. So I guess one immediate thing that comes to mind is that I think that intuitively, it seems like basic motor skills, like picking up objects and pouring, they seem like they should be really easy tasks. They seem they're so intuitive, they're so basic, they're things that we can do like almost in our sleep. And yet actually getting robots to perform these kinds of tasks is actually really difficult. And it turns out that we have AI systems, machine learning systems that can play chess, for example, or can play Go. And it's a little bit counterintuitive that, at least in terms of recreating these kinds of abilities, it's easier for us to solve these seemingly very complex problems, yet really struggle on the basics, like picking up objects in a general way. And so that's something that I think is always somewhat surprising. And there's actually a name for it. Moravec's paradox it comes from a professor, I think at CMU, who also observed this kind of phenomenon as well. And yeah, it's something that I think always continues to surprise me, because it seems like we should be able to endow robots with these really basic but general manipulation skills, but it always turns out to be more difficult. The other thing that I think often surprises me, or especially can be surprising to people who don't work a lot with real robots, is that sometimes when you think about a problem, maybe you think about developing a robot that can do something in simulation, there are often a lot of shortcuts or assumptions that you make. And then when you actually try to go towards the real world, some of those assumptions are no longer true. So for example, in reinforcement learning, typically you think about it as an episodic setup where the robot tries the task in one episode, and then maybe it tries to like pour water from one cup to another cup. And then after that first episode, it gets some feedback, and then it tries again and so forth. And one of the things that we typically do is when you keep trying the task over and over again, you always start from a similar state. Like maybe you want to pour from a cup into another cup, and maybe the right cup you always start with the setting where the right cup has water in it. However, after you've attempted the task, you're no longer in that initial state. And so if you want to try again, you actually need to get back to that state where there's water in the right cup. And so when you're working in simulation, you can always just kind of call the reset and kind of put things back where they were in simulation. But in the real world, you actually need to think more critically about this, especially if you care about robots that can autonomously learn and autonomously improve with experience.
Yeah. You mentioned a very interesting thing. I'm curious to ask you, do you think what is maybe lacking here? Do you think we need more models to understand how this happened already? Where do you see maybe the bottleneck in this? What's surprising you, so that we can, or you can achieve what you really think that's exactly what we have in evolutionary nature to figure out
so
this on.
Yeah, for this particular shortcoming that I mentioned about assuming that you can kind of always reset the environment back to some initial state and try again, there's potentially actually nothing inherently wrong with, nothing inherently bad about this, but actually the kind of where the challenge and where the issue is that if you take reinforcement learning algorithms and you don't give them this reset, it turns out that they actually work a lot worse. They actually can't learn the task when you don't give them this kind of episodic reset to an initial configuration of the world. And so for that particular problem, I think we need better algorithms that can learn continuously and learn fully autonomously without having this rather artificial setup. And in general, for the problem of being surprised when you go to the real world, I think that having more people who actually experiment in the real world, more people who actually like touch the real world a little bit more and so forth can really open your eyes towards towards the kinds of challenges and assumptions that aren't true in the real world and so forth. And so, yeah, for people who are interested in making contributions in robotics and so forth, whether it be from a perception side to a control side, I think it's really good for those people to try to actually work with hardware and see what comes up and where all these challenges are, rather than staying in simulation and assuming that everything will transfer over.
Yeah, that's a good point. But I'm curious to ask you, because you mentioned interaction with environment is very important, but when it comes to simulation for environment, sometimes it's very expensive. How do you see the trade-off between using this robots very expensive? Sometimes you don't have access sometimes with them, and simulation to see this environment. Do you think it's important to see this trade-off as well in simulation?
Yeah, there's certainly a trade-off. I think that, I mean, one is just the cost of buying the hardware itself. And one thing that we've done in my lab actually is we have some nice robots, but we also have some lower cost robots as well. And during the pandemic, we actually had some students working with low cost robots at home, where there's maybe a slightly lower risk of transporting it to their home and maybe a lower risk of it being damaged and so forth, because it's a little bit less costly. And so I think that that's one way to mitigate these risks. And I hope that the price of robots will also decrease in the future. And then I guess another cost is that it just takes longer to run experiments in the real world. And I think that in some ways that cost is worth it, at least in terms of spending some time on the robot. Because I think that if you always spend 100% of your time in simulation, then you miss out on actually where some of the biggest challenges are.
Yeah, true. So I'm curious to ask you about, because we need to ask about that, what do you think to be the biggest limitation when it comes to learning now? And when you see this, like, not only research, but in general, biggest limitation, and you think we have to go in this direction, or you think maybe we have to give more attention to this direction? What that thing would looks like?
Yeah, I think that there are two limitations of learning. One is that I think that really to reap the benefits that we've seen of machine learning in other fields, we really need to scale up data and move towards reusing data, like I was talking about before. And if we don't do that, then we aren't going to generalize very well. And we won't see all of those benefits that we've seen in areas like NLP, computer vision, and speech, and so forth. Those are all fields where people are actually using machine learning deployed in real world settings, whereas in robotics, I think we haven't really quite gotten to that point. And so I think that there is that challenge, and I don't really view it as a fundamental limitation. I just think it's something that we really need to figure out as a field to move towards these kinds of settings that we see the rest of machine learning operating in. And then the second limitation that I see is that once we do get to that point where we're training on a lot of very broad data, one big challenge with machine learning methods at that point is that if you provide the model with observations that are outside of the distribution of the training data that are a bit different, maybe there are outliers, maybe it's a long-tailed distribution and you're seeing a lot from the tail of lots of different conditions that might come up, then these machine learning systems do tend to struggle when there is this distribution shift, when things are different from the training data, even when you train on very broad distributions. And so I think that if we can figure out how to get to where some of those broad distributions, get to the point where robotics is operating on very broad data sets, then I think the challenge that we'll see after that is also trying to provide robustness when things are a bit different from the training distribution, or at least having the robot recognize when it's in one of those situations so that you can call for help or something like that.
Yeah, good point. Yeah. But I'm curious to ask you about the computation when it comes to, you mentioned sometimes you have this kind of expensive computation. I think when you maybe where you speak about this kind of a memo, for example, to circumvent this wave computation. But if you can tell us more about when it comes to learning, how maybe you deal with expensive computation, and do you think what kind of maybe beyond something, yeah, you think you have to reach maybe? Do you think a machine has to be conscious when it comes to continual learning, to be conscious so that it can learn on their own? What kind of maybe other aspects of intelligence do you think you need to embed in the robot, for example? Do you think maybe, I don't know if you have any ideas, maybe beyond what we have?
Yeah, so with regard to computation, I think that in some ways it's inevitable. I think that robotics is such a challenging problem because you need to perceive the world and you need to, I don't know, it's such a challenging problem to be able to control your environment and control lots of different environments and so forth. So I think that inevitably we will have to, we'll have to, I don't know, spend a lot of compute to solve it, I think. And arguably we do have one kind of existence proof of humans, and humans do also expend a lot of computation as well. Although the human brain is much more energy efficient, I think, than the typical computer, of course. So in some ways, I think that's inevitable. And then I think your second question was,
yeah, I don't know if you, because you're so passionate about what you're doing, I don't know if you think maybe other aspect of intelligence you think you need to embed in your robot, for example, conscious robot. Do you think when it comes to learn for yeah, like continual learning, do you think consciousness it's important of a machine, or just something that doesn't make sense to you? I'm just curious about your thoughts on that.
yeah, I think that there are lots of different aspects of intelligence that robots need. With regard to consciousness in particular, I don't feel like I personally have a kind of full understanding of what consciousness exactly entails. And I think that different people use it in different ways. I think that if it means the ability to, I don't know, reason through a situation that is different than previous situations rather than acting in a very reflex-based manner, then I think that aspect is important, because I think that inevitably robots will be in different situations where they can't just kind of out of reflex apply what they've learned in previous situations. They need to actually think things through a little bit more carefully. So I think that that's important. If that's in particular what we're thinking about when you're saying consciousness. But yeah, I think that there's, yeah, I'm not exactly sure what consciousness means in different circumstances.
Sure. Yeah. So maybe I have one question from the audience here. How can we learn a robotic arm forward and inverse dynamics with deep learning or machine learning in general?
Yeah, so we use machine learning to learn both forward models and inverse models a lot, and I think that it's a great tool, and I'm in general a fan of approaches that learn these kinds of models. In particular, we've done a lot of work on learning forward dynamics models actually in the raw kind of sensory modality space. So if, for example, your sensor modality is an image because you have a camera, we've actually been learning forward dynamics models in image space where you're predicting future video as a function of the current image as well as the robot's actions. And this is a very difficult thing to learn, but if you can successfully learn it, which I have some hope for, then there's so much that you can do with it, because you can plan with it, you can do different kinds of optimizations to learn policies and so forth. And so I think that it's a really promising approach for learning a variety of behaviors. And it's also an area where if the robot collects a lot of data, which it can often do without any human supervision, then it's basically just a supervised learning problem where you just kind of train a neural network to output future video as a function of the current image and the actions. And in general, we've seen in machine learning that supervised learning with large data sets and so forth is usually a pretty good recipe for training models. and for training neural networks.
Yeah. So maybe for a student who listening to you, what could be the technological roadblocks when it comes to your work or in the lab, what you're doing? Maybe short-term and long-term technological roadblocks do you think so challenging for you?
Yeah, lots of things. I think that one challenge with what I was just mentioning with learning these models of sensor observations, we actually done it both for cameras as well as for tactile sensors as well, and the same sort of ideas can transfer across sensor modalities. But one of the challenges that comes up there is I guess, is mainly two challenges. One is the future images are not a deterministic function of the present and your actions. There's uncertainty, there's things that you can't observe about the world. And so it's not just about predicting one future, because there's actually multiple potential futures, and you actually have to have your model be able to capture that the fact that there can be multiple possible futures, which introduces some challenges because you need to get a little bit into things like probabilistic modeling. We've used tools like variational inference, Bayesian deep learning, and so forth to do that. And another challenge is that beyond the fact that there are multiple possible futures, there's also it's just a huge space. If each video frame is like, I don't know, 200 by 200 by 3 for 3 channels, and you want to predict like, I don't know, even just 10 time steps into the future, then you have a massive quantity of numbers that you need to predict. And so it turns out that, at least we've been finding, that we need to train larger and larger models in order to capture all of the richness of the real world. And we're at least currently running a little bit up to the bottlenecks of hardware like GPUs, the amount of memory on GPUs, the training times, and so forth. So that's at least one bottleneck for that particular kind of approach. Another roadblock that we can sometimes run into is just thinking about how to collect data and where the data should come from. Can we use data from the web, for example, to train robots? Like, there's lots of videos of humans on the internet doing things, and that actually has a lot of information about the world and how to interact. And yeah, just this challenge of thinking about where our data should come from, how do we get it, and how do we collect more data? What data should the robot collect? Yeah, lots of important and interesting challenges.
Great. So I think so goes to end. I have a few questions. The first one, what could be most impressive thing, maybe when it comes to machine and artificial intelligence field, you think is very impressive to you, and also for MetaLearning, if you have any example that's very impressive to you. Do you have any favorite or very impressive thing done so far?
It's hard to pick just one. I think that a lot of the work that in general, I think that a lot of the work that we've done on real robots is usually one of my most exciting things, because actually seeing something in the real world is so much more compelling than looking at like a little robot on a computer screen in simulation. And so some of the things that I've been excited about are works that we've done where you could essentially give the robot a video of a human doing something, and then the robot can look at what the human does and then kind of figure out how to perform that same task in its own environment with the objects in its environment. And so we call this one-shot imitation learning, because the robot is imitating the human and it's doing so with just one video of the human. And so some of that direction I think is always exciting. We've also done some work on legged robots, where the robot is learning how to walk on a new terrain or walk up a slope that it hasn't been on, or with a payload. And we've seen how robots can adapt actually in real time, oftentimes, to these kinds of changes in the environment. And I think that things like that are also really exciting as well. Yeah, and then I think that just in general, things that push the boundary of the variety of scenarios the robot can handle and the versatility of the robot are really exciting to me as well. Because I think that, I guess early on in my PhD, we were able to show that robots can learn very narrow but complex tasks. Like, I had a robot use a spatula to lift an object into a bowl, which I thought was pretty cool and also a pretty challenging task, but it was very narrow. And so now I think that really the core challenge is is getting robots not that can do one narrow thing, but can do a variety of things in a variety of environments.
Great. But maybe a quick question about redundancy, or because we have a question how if the damage is happened to the robot, or for example, what kind of redundancy do you expect the robot to adapt to this kind of damages or maybe change? I don't know what do you think about resilience in general when it comes to design of robots, or maybe when it comes to MetaLearning, what you do. Yeah, because there's a lot of work in that. But if you can tell us what could be exciting, maybe still limitation to have this kind of resilience or redundancy.
Yeah, absolutely. I think that resilience is super important, and it's some ways it's things coming up like damage or something unexpected happening is somewhat inevitable. And I think my perspective on it is that first, the robots, I think it's okay for the robots to fail in a couple times. I think that maybe that's somewhat inevitable, although if anyone can make a robot that never fails, that would be awesome. What's more important is not that they don't fail at all, but that when they do fail, they're able to kind of learn from that failure, learn from that mistake, and adapt in a way that quickly adapt and kind of get back on a good course. So for example, I was mentioning how robots can adapt online to different terrains. And in the context of that project, we actually also showed how you could, this is like it was like a 6-legged robot, like the size, like less than the size of your hand almost. And we took off the front right leg of the robot kind of to simulate the process of there being some damage to the robot. And we found that it did like fail in some way. We were telling it to run in a straight line and it kind of veered off of the straight line, but it was able to adapt and it was able to kind of adapt its model of the world to the scenario where it doesn't have a front right leg and kind of get back on track. And that's exactly what I'd like to see in robot systems. And I think that tools like MetaLearning, which we used in that project, can be quite useful for it.
Thank you for sharing that. Yeah. So I think we need to also ask about PhD, because you mentioned your PhD was like you playing with what you do, and that's very, very interesting. That what do you think when it comes to PhD, for example, to select a topic and make sure you're passionate? Because I like what you say, that you enjoy something, and that's what we have to do. But when maybe a student listening to you, how we make sure that you enjoy and you don't feel that you work hard, just like as you said, play with something.
Yeah, absolutely. I think that this differs by area in general and so forth. In computer science, I actually think that it's good to explore a little bit at the beginning of your PhD. I think that you don't need to pick something right off the bat and go with it. There is a little bit of a balance. You don't want to be like completely exploratory and explore things that that are maybe kind of too far from I don't know where your expertise is maybe, but in general, I explored a lot at the beginning of my PhD. I did a lot of work on kind of a lot of work on robotics and so forth at the beginning, on just learning individual tasks, and then that motivated a lot of the work that I did on MetaLearning and on learning general purpose models, because I was very frustrated by the fact that we were just training the robot to do one thing and throwing away all the data and then training it to do another thing, which just seems so wasteful. So I think it's good to explore, and that will help you, I don't know, figure out what things you don't like, what things you like, and so forth. And then my other thought on the topic is I think that oftentimes people talk about like passion and there being like this one thing that you're passionate about. And I think that there's maybe a little bit of a misconception there that like, I don't think that there's necessarily like one thing that's your calling. Maybe for some people there is, but at least for me, it was more about finding things that I enjoyed, finding problems that I felt like were the most important problems to be working on. And once I got to that point, and once I was enjoying what I was doing and really excited about what I was doing, at that point, I was happy at least, and it also made it easier to work hard because I really enjoyed what I was doing and I didn't really feel like I was working.
Yeah, and I'm curious, do you think ego for you is important? Because with academia sometimes it's ego driven. For you, ego is important when it comes to you have new ideas, or is ego important for you?
I think that academia is a little bit of a weird a little bit weird in this sense. I think that you need to have a thick skin because there is a lot of rejection that you have to face with regard to negative reviews, papers being rejected, grant proposals being rejected. And I think it's important to have a thick skin to a lot of that because there's a lot of randomness in the review process. Sometimes the reviewers that get your paper work in a little bit of a different area. Maybe they didn't have a lot of time. And so it's important to have resilience to that and to have a thick skin and maybe have a little bit of an ego with regard to the work that you're doing. But at the same time, I think it's also really important to be humble and so forth, because I think that research is just really, really hard. And you don't really know. I mean, I think that no one really knows what the right answer is and what the solution will look like, especially in 15 years and so forth, like what work will have the most impact and so forth. And yeah, what exactly the solution will be to the problem. And so to make progress, you need to, I think it's helpful to be open-minded and to, I don't know, recognize that it's a really hard problem and that you don't know how to solve it. Because if you think you know how to solve it, then you're probably not right, at least for the very long-term problems.
That's a good point. And maybe I'm curious if you would like to share with Ori, what's your aspiration, maybe when it comes to research? Aspiration for you, what kind of your goals on the aspiration? You every day you think, I want to reach that goal.
Yeah, I think I personally have a few aspirations. I think on the technical side, on the robotic side, I don't know if this is achievable, but I'd love to get to the point where we can put a robot into a place that's never been before, like maybe a kitchen that it's never been before, a home, and have it do something useful, like make a bowl of cereal in a kitchen or make a bed in an environment that it's never been in before. And this seems, like I was mentioning before, so basic to humans. This would be so like really not hard for humans to do. But it's incredibly difficult for robots. And if we could do that, I think that would be pretty amazing. So that's on the technical side. And I guess also on the technical side, like I guess on the machine learning side, for example, I think that also trying to contribute to knowledge of machine learning, trying to kind of develop new capabilities and so forth, and also in some ways actually applying those to real problems as well is important. And then beyond the technical side, I also really care about my students and their experience in the PhD, and that includes both creating a really great environment for people to do great work and to learn and to enjoy their PhD or their master's degree or their undergraduate degree and so forth. And also beyond enjoyment, also just learning a lot and growing into a great researcher and scientist.
That's great, yeah. I'm curious also what could be the most important quality you have to maintain? Would it be in academia? Yeah, maybe one important quality, what that is?
I think that it's hard to name just one. I think that one that comes to mind is curiosity. Mm-hmm. I think that if you, it's a little bit weird to say that because in some ways I think that I don't really associate myself with being super curious, but I think that if you're really eager to solve problems and want to figure out things and solve puzzles and so forth, I think that that will help someone go far.
Mm-hmm. And lastly, maybe is best advice was given to you? Maybe I was a life changing, or stick to your mind every day. Advice was given to you.
I don't think that there's any one piece of advice that has really stuck with me. I think that the things that have stuck with me are people's approaches to doing things and what I've seen people do rather than what they've said. Okay. For example, my undergraduate advisor at MIT, he was really passionate about the work and research that he was doing, and that influenced me to think about research more. I also think he really cared about teaching, about all the students and everything and so forth, and that was something that I really admired. And he also did a really fantastic job of recognizing the kind of maybe sort of power imbalance between faculty and students, and recognizing when something would come down hard if a faculty said it versus if a TA or a student said it. And so he also had a lot of this emotional intelligence maybe, or kind of people skills as well. And so that's one thing that I think has stuck with me a little bit, and it's a little bit weird that it still feels a little bit weird to me to imagine that students view me in the same way that I viewed a lot of my professors in college. And so I try to keep that perspective in mind.
Yeah.
Yeah, so that's one thing that stuck with me, I think.
That's a very humble point, because some people forget they were at this point, and I think that's very, very, very important point what you say. Thank you for saying that. Thank you. I don't know if you have any final words you would like to say, and maybe for the audience, any final words you'd like to say?
I guess one additional thing that I'll add to the previous comment and question is, I think that one thing that I've learned also is that you don't have to do everything yourself and figure out everything yourself. I think that it is good to rely on mentors and teachers and try to learn as much as you can when you have opportunities to learn from those people. I think that's been helpful for me as well. Yeah, and then I don't think that there's anything else that comes to mind. I think that we covered a lot of ground.
So thanks so much, Chelsea. It was very inspiring and sharing your interesting work. I wish you all the best, and thank you once again. Such an honor to have you. Thank you.
Yeah, thank you for having me.
Thank you.